Alright, now for the last section of chapter 10. And here we get into basically how we group stars. Now, we talk about categorizing them as red dwarf, red giant, and so on in the last section here. Now we're going to be looking at how they're grouped just naturally in space, some of the patterns we see there. One is simply the binary star system, in which two stars are bound together by gravity. Basically, they orbit around each other. They circle each other in the same way the moon revolves around the Earth. Now, our solar system is a lone star, or single star. Some other star systems, we've noticed that there are binary stars, that they move around each other. Now, there is a phenomenon also called the optical double. These are a pair of stars that are close on the celestial sphere, where we might at first assume that they are a binary star system, but in reality, they are very, very far away from each other in space. It's just that all along the celestial sphere, it makes it look like they're close together. Because again, the celestial sphere is only two-dimensional, and space is actually three-dimensional. There are also triple stars. These are made up of three stars all orbiting each other. And then there's also multiple stars made up of more than three stars. Each individual star orbiting its partner while the two pairs spin around a common center. Even larger stellar groupings within a galaxy are called star clusters. There are two main types of clusters. That is the open cluster and the globular cluster there, numbers 6 and 7. Open clusters are loose asymmetrical clumps containing tens to hundreds and, on the occasion, thousands of stars. Globular clusters are basically just bigger. Tightly clumped spherical group of thousands or millions of stars travel outside the boundaries of the Milky Way in unusual orbits around the galaxy's center. So part of our galaxy, but definitely not part of our solar system. Let's see. And we move into some things that we do see, or we've seen evidence of, and these are the explosions. Nova. When a star suddenly flares up to many times its original brightness and eventually returns to its original magnitude. That is what a nova is. The star continues to be very bright for some time, eventually returning back. All nova observed so far seem to be white dwarf stars in binary star systems. So it could have something to do with the density of a white dwarf star, as well as the gravitational pull of an additional star around them. Astronomers speculate that the hydrogen gas from the system's larger star collects on the surface of the white dwarf and occasionally explodes, resulting in a temporary outburst of energy. After the hydrogen burns up, the white star returns to normal. A few stars flare up into nova as often as every 20 years. Unlike a nova, which leaves a star unharmed, we have the supernova. This is the explosion of a star, a cosmic catastrophe of amazing violence. From a once faint star quickly develops one of the brightest stars in the heaven. In a short time, however, the light fades, and all that remains is the hot, dense core of the star, surrounded by an expanding nebula, a cloud of interstellar gas and dust. And this could leave behind a neutron star. This is an extremely dense, hot core of a star left over after a supernova. Only a diameter of about 12 miles, but more mass than our sun packed in there. And then a pulsar is a rapidly rotating neutron star that emits directional beams of radio waves. And that's kind of what this picture here is at the bottom. Out the two pole ends, we see beams being shot off there. And there are radio waves. Where'd it go? Some pulsars also send out beams of visible light, X-rays, or gamma rays. One pulsar known for releasing pulses of visible light is the pulsar in the Crab Nebula, the remnant of a supernova seen in AD 1054. So there are probably records of that one, actually, of 1054 there. And if you've ever watched Star Trek, especially the older version of Star Trek, the United Federation of Planets, they have a symbol on their shield, and it's all these different stars, and I don't know if this is true, I wasn't able to look it up, but I remember hearing once that those are supposed to be pulsars, because pulsars kind of act like lighthouses, in a sense, setting off a very distinct frequency, and you can use that, it would be conceivable to use them as ways of mapping the solar system and moving around it. Little note in our book here, some pulsars rotate more than 700 times every second. or 42,000 times every minute. Then we get into, away from individual stars, into the galaxies. Galaxy is a massive star system containing millions to billions of stars, as well as gas and dust, which we'll look at some of that later on. Our galaxy is the Milky Way galaxy. It contains over 400 billion stars. And since we observe from the inside of our own galaxy, it's really a bunch of educated guessing as to what our galaxy really looks like from the outside. Like I said, it is educated guessing. It is based off of facts, but there is some room for error since we are observing from inside of our galaxy, trying to look out and picture our galaxy. Galaxies are not spread randomly throughout the universe, but they are grouped together in orderly, complex structures, which at one point was not thought to be the case, but as we've done more study about the solar system and other solar systems and galaxies, we realize that there is more patterns than not. One such pattern is a cluster. This is the smallest organizational group. The Milky Way is one of more than 30 galaxies in a cluster known as the local group. This does include the Andromeda Galaxy, which is the largest galaxy in the local group, as near as we can tell at least. The only other relatively large galaxy in the local group is the Triangulum Galaxy. Most of the galaxies in the local group are clustered around the Milky Way and Andromeda Galaxy. And again, if you look on page 361 in our books, you'll see a very good diagram kind of showing this way of grouping stuff between clusters, superclusters, and so on. Two of the closest galaxies to ours are the Large Magellanic Cloud and the Small Magellanic Cloud, both visible with the naked eye from the southern hemisphere. Contain several billion stars, only about 200,000 light years away from the Earth. There are at least two tiny galaxies closer to the Earth than the Magellanic Clouds. Astronomers believe that clusters are grouped into larger structures called superclusters, which we have there at number 5. They appear to be joined together to form the walls of vast ball-shaped structures, three-dimensional, that are almost empty in the middle. So it almost appears as if these clusters and superclusters are grouped in such a way as around something, but there's nothing in the middle, at least that we have observed so far. This brings us to galaxy shapes. And this includes our own, the Milky Way is believed to be a spiral galaxy, as well as the Andromeda Galaxy. Look like giant pinwheels, the bottom left picture here, spinning through space. I don't think that's a picture of our actual galaxy. After all, it is mostly red, and I don't believe our galaxy is mostly red, if I remember the pictures right. But it is a good example of a spiral galaxy. And even after that, even a barred spiral galaxy. Presently, astronomers think that the Milky Way is a barred spiral galaxy with two major arms and several smaller arm segments. Until the 1900s, most astronomers thought the Milky Way was the only galaxy in the universe. We now know that the universe contains many other galaxies. Presently, the estimate is around 120 billion galaxies. And we've actually already talked about clusters and superclusters. Oh, yeah, there it is, the spiral shape. All spiral galaxies have a central nexus, which you see, or nucleus, which you see there, the bright spot in the middle. Resembles a flattened ball, which the arms are attached to. The arms seem to spiral closely about the nucleus if it is large, and they seem to spiral rather loosely if the nucleus is small. In some spiral galaxies called barred spirals, the spiral arms are attached to a straight bar that runs through the nucleus of the galaxy. And then, like I said, because we're trying to observe our galaxy from the inside, there is a large, thick veil of stars between us, or around us, that just obscures our study to a certain degree. And as a result, like I said, there is some room for error here, but presently astronomers think that our galaxy is a barred galaxy. Our sun is located towards the edge of the galaxy in one of the spiral arms. The center of the galaxy is in the direction of the constellation Sagittarius, where scientists have found a very small but very dense object called Sagittarius A. Scientists believe that this object is probably a black hole, an object so massive and dense that not even light can escape its gravity. So you may hear scientists, specifically astronomers, sometimes talk about black holes being near the center of galaxies. And this is one reason why, because as near as our observations can tell us, the characteristics of something near the center of our galaxy would fit that description of a black hole. Very dense, very small. So, three other shapes for galaxies. The elliptical galaxy, right next to our spiral galaxy here, resembles an egg or footballs. And compared to spiral galaxies, elliptical galaxies are not as structured, do not contain as much free gas or dust. So that's an elliptical galaxy. Then we have the lenticular galaxy, flat with a bulging nucleus. However, a lenticular galaxy has a solid disk instead of spiral arms. And here, the third picture from the left, we have a picture of a lenticular galaxy from a side view there, where you can see the nucleus bulging outward there. And then we have the irregular galaxies. These are composed of stars clumped together with no specific shape. And that's all the way on the right-hand side of our picture there. And there were many examples I could have chosen from for that off of the internet here. And then we have, there we go, quasars and nebula. And quasars are quasi-stellar radio source. That's what the word quasar stands for. It's an extremely bright object that emits both visible light and radio waves, in one sense similar to a pulsar in that respect. Some of the brightest known objects in the universe are quasars. And probably not more than a few light days across. They're usually located at the centers of galaxies. Scientists believe that each quasar is made of a large black hole surrounded by a glowing ring of gas called an accretion disk. The gravitational pull of the black hole compresses the accretion disk, causes the gas to heat up. The gas of the accretion disk heats up so much that it glows extremely brightly. Most quasars are so bright that the light from their associated galaxies is often difficult to see. So the quasars are actually are bright enough that they drown out other light. And then another common phenomenon, at least in the Milky Way galaxy, are nebula. And I have three pictures of nebula here. The Horsehead Nebula, a Butterfly Nebula from the Hubble telescope, and then what's also referred to as the God's Eye Nebula. These are large clouds of gas and dust floating in space. They're most common in spiral and irregular galaxies. Remember, lenticular and elliptical galaxies had almost no free dust and gas just roaming around. Most nebula are too faint to be seen with the unaided eye. Some of these nebula would appear larger in the sky than the full moon if we could actually see them. But because they are a loose collection of dust and spread out over quite a distance, they just don't reflect enough light that we can see them without help. A large telescope is needed to see the majesty of these clouds. And these nebula are sometimes some of the most beautiful things in our universe as we just look out and see different shapes and different coloring even among these nebula. Thus ends Chapter 10, one of the longest chapters in our particular book. We will be having a test soon, so make sure your notes are ready for that. And go ahead and answer the science video question, and I will see you with one of our final chapters coming up.